y equals 2 over 3x squared plus 1 to the power of 5? Well, there are at least 3 ways to solve this, at least. One of them is going to be like this. We are going to rearrange everything before solving it. So we are going to have y equals 2 times 3x squared plus 1 to the minus 5. Why minus 5? Because you take this all, if you take all this up and it's multiplying that number 2, you have to change the sign of that 5. So you change it here, and that's how you get this kind of function rewritten. So you can solve it like this: y prime equals n, or that is k, right? That is a number. 2 is going to represent the letter k, and then it's going to multiply n times u to the n minus 1. And then we have to multiply all of that times u. I didn't know I could do this. Times u prime. I'm going to explain that to you all of this anyway. The other way to solve this, but it's not you could do it. I know, remember, Andrea, that you were solving it that way, like u and v? Why? Yeah. Okay, you could do it like that, u over v. So it would be u prime v minus v prime u over v squared, but I do not recommend you this one because it's too complicated and too long. There's another one that we're going to learn today, and it's the chain rule. So the other one would be the chain rule. How does it work? The chain rule means that you're going to multiply two fractions. What does that mean? If you have a fraction, let's say you have a number 5 on top and a number 7 in the bottom, and then you have a number 7 on top and a number 6 in the denominator. You can simplify this fraction by canceling the 7s and saying that you have 5 over 6, and that is your final answer. How do we do it and why do we do it? Because we can say that we have a whole fraction line, or yeah, one of the ways. We have a whole fraction line, and then we have 5 times 7 over 6 times 7. Because I'm just switching the factors, and we can say that 7 over 7, this equals to 1. And that's how we get 5 over 6 in this case. Or we could say 5 times 7 over 7 times 6. So, but you don't want to multiply them, you want to simplify them. So you get 5 over 6. Why am I saying this, and what do we do with this information? Okay, because
Miss, can you please undo?
Undo? Okay. I will. Sorry.
Okay.
Up to there, yeah, because that is better. So you have those ways of canceling things, right? I can say 7 over 7 because they're multiplying. They don't have a positive or a negative sign between them. So I can cancel them and say this over this is the same. It is equal to 1. When I multiply 1 times 5 over 6, I get 5 over 6. Why am I saying this, and what does it have to do with the chain rule if we were going to work with derivatives? Okay, I'll show you. When we have the chain rule, we have to use the change of variable. Okay, so I'm going to identify them. You know that the derivative of y, so it could be represented as this, and the other notation for that would be dy over dx. One of the other possible ways we can find the notation for this. So that would be the derivative of the function. But we are not going to see it that easy. When we have a chain rule, it means that we have a function inside of another function. It sounds worse than it actually is, because I'm showing you one of the ways you can solve it like this, and you know how to do it because you always you take it as all of this is u, and then you find u prime. So you have u equals to 3x squared plus 1, and then you find u prime, which would be 6x in this case, and you plug everything there on top. And of course, the number 2 is represented by k, or k is represented by that number 2, so you're going to plug it here, and the n equals to -5, and that's why you're going to plug there. So you know everything, and you know how to plug it there, so you will get the answer just by identifying u, finding u prime, identifying k, identifying n, you plug it there, you get the answer. The chain rule says, okay, you have a function inside of another function, and this is how we're going to solve it. Okay, so let's check it out. I have dy over dx. The thing is that I'm not going to find dy over dx that easy. But it's going to be easy in the end if I help you identifying everything. The dy over dx is going to be dy over du times du over dx. What? It looks horrible, I know. But u is right here, right? You have u and you have u over there. It means that if you multiply dy over du times du over dx, you can cancel those du's. So your final answer is going to be dy over dx. So from you want to get here, but you have to identify then dy over du times du over dx. If you don't want to do it this way, this is one of the ways. If you don't want to do it that way, we have another way, and this is the chain rule. Okay, how do we work? We identify u. U, in this case, we said was going to be 3x squared plus 1. So we identify it, and we say u is 3x squared plus 1. Then if I want to find the derivative of that, I know that is going to be 6x. Why 6x? Because I have two terms, this term and it's adding this term. So I'm going to find the derivative of the first one and the derivative of the second one. And I'm going to add them, okay? So the derivative of the first term, it would be 3x squared. How do we find it? We leave the 3 outside because it's a constant, and we find the derivative of x squared. But to do that, I say, okay, I have x and I have n. I have a power or an index that is different than 1. So the way for me to find the derivative of this is saying that I take n down times x to the n minus 1, right? So I take 2 down times x to the 2 minus 1. So I get 3 times 2 to the x to the 1, because 2 minus 1 is 1. 3 times 2 is 6. X to the power of 1 is x. And that's how I get the derivative. I know I did it super fast on the right side, but now I'm showing you how to get it, just in case, okay? Then, the thing is that if I'm finding the derivative of u, there's another notation. The one in orange, I'm going to highlight this in, or say that this is the orange thing, right? I'm finding the derivative of u. In this case, I'm not going to put that prime on top of the u, but I'm going to say the u. So the derivative of u. It's the same. I get the same answer if I find the derivative of u, or the derivative of u is the same, but with a different letter, or the apostrophe, or this prime changes for a d in front. But if I do that, and my variable here was x, I have to put a dx. So the derivative of u with respect to the x, to x. What I'm saying there is that my variable is x. If I don't want to see it that way because it's a little confusing or complicated, I say the derivative of u right away over the derivative of x over the function, over x, because I'm finding the derivative of x, it equals 6x. So I have, if I want to plug, it's always about plugging things. So if I want to plug something there, I have du over dx. I need dy over du before, so I can multiply them and get dy over dx. Well, that is many, those are many d's, right? dy, dx, blah, 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 blah. So y, what was y? Remember that we rearranged y and it looked like the first one. I'm going to say that this is the first, the second, and the third way. So in the first way, we had y equals 2 that multiplies u to the negative 5. So I'm going to say u to the negative 5. I don't want to see everything that is inside the parentheses. 3x squared plus 1, it scares me, so I don't see it. I'm going to say, I want to find the derivative of this, only this. How do I do this? Okay. The derivative of y, but what is my variable on the right side? Is that an x? Not an x anymore, it's u. So that's why I'm going to say that I have the derivative of y over du. And now I can see, yeah, now I say the derivative of y is equal to, and I apply the same formula that I have here, or actually just u to the power of n and k, but it's going to be the same. So I leave 2 outside, I take n down, so it's minus 5 because n equals minus 5. Then I have u, and I say u to the minus 5 minus 1. You see? And down u to the minus 1 minus 5 minus 1. That's what I have here. Times u prime. But okay, the u prime. So what I have here is, actually, I'm not going to use the prime here. Okay, I have dy over du is minus 5 times 2 minus 10, okay? Times u to the minus 6, because minus 5 minus 1. That way, I can say that I have dy over du. That's it, simple. Now, what I have to do is to multiply du over dx times dy, it doesn't look like a times, okay, dy over du. And that is going to give me dy over dx. I'm going to cancel the u's. And that is going to be 6x times minus 10 u to the minus 6. Okay, so I have 6 times minus 10 minus 60. X, because I cannot get rid of this x, so I repeat it there. U to the minus 6. But I was canceling the u's. My answer cannot be expressed in terms of u. But I said u was going to be equal to 3x squared plus 1. So I'm going to change it, and I'll say minus 60x times 3x squared plus 1 to the minus 6. And that is going to be my final answer. And that's how I find it in a different way. So number 1, I'm going to erase number 2. It's going to give me the same answer if I do number 2, but let's not go that way. Another notation for this would be f, and this is like a circle, an open circle, f circle g of the function of x. It means also that I'm going to plug g into f. It's always the one on the right into the one on the left. Okay, so to find the derivative of these kind of functions, we are going to follow steps.
3 is the value.
Is the input. Remember that we had input and output. So the input in this case is 3. So if you plug a number 3, right. You see? So if you plug that 3 into the function, they don't give you the function. They don't give you the function. They say you plug the 3 into the function and you find the derivative of that, you get the blue answer. What are we going to do with this information? Look, I did it like this. You plug first. You plug into the closest function.
What does that mean, closest function?
Thank you for asking. You plug 3 into the closest function.
Oh, okay.
You see?
So
You
it's like
plug.
the physically closest one to the.
Yes. That. Yeah. Is that? I did it with simple words. So we could see. Oh, this is what I have to do. So it means that if you plug 3 into the closest function, thank you. You get the value of b in this case. Yeah. So you get b. So then the original one, once you get that b, you're going to plug it into the derivative of the other function. So you are going to find that b, yes or yes, they're going to give you the value of b here. And once you find that b, you identify it here to get the value of e. So what are we doing here? We're choosing the number 3 into the closest function. We check, okay, I have b and I have d. I'm going to use b to find the e of the derivative of the other function. So what I have to do now is to multiply. We're going to do it with numbers, so don't worry. But I need you to write the steps down so you always know what to do. And then you have to multiply the derivative. So you have to multiply d times e, or e times d, and that is going to be the answer. Yeah, I know it looks, that gives you the answer. But this is the generic way. Okay, now, we plug the 5 into the f, right? To find the red. If we don't remember the letters, let's do it with colors. I remember with colors better. So B, oh yeah, B was the red one. So I plug 5 into F. So when I plug 5 into F, I get 2. So B equals 2. And then I found the blue one, if I'm not mistaken anything. And that would be find 5. When I plug 5, it would be D. I get -1. You see it? Then, how do we find E? We plug that number 2, this number, into the other function, but in the derivative of the function. So we get 0. And E equals to 0. Then we multiply D times E. And in this case, 0 times -1 is 0. Let's see if I made it right.